Hey guys, and welcome back to a new video for the Roblox scripting tutorial series. In today's video we'll be teaching you about the most common and useful object methods. I will be covering the following: destroy, FindFirstAncestor, FindFirstChild, FindFirstDescendant, WaitForChild, GetChildren, GetDescendants, is-a, and finally. Alright, so first of all, in order to actually teach you how object methods work, I will need to tell you how to call them. So I will be adding a part inside the workspace, which we will be using throughout the whole video. I will make sure it is anchored, and I will also add a script here in this part. Now, for example, one of the methods we can use is, for example, destroy. So if you wanted to call that method, you will have to first of all reference the instance, the object, and then type column and the method name. You can see here how there are a lot of different methods, but we will only be covering the ones I mentioned previously. Alright, so as I said before, the first method is destroy. This is quite straightforward. You just type here, of course, destroy, and you do not need to pass any parameters. What this will do is it will simply destroy this part, right? So I will make it so the script waits 5 seconds before actually destroying the part, and that way we can see how the moment it is destroyed. So I will run the script, and here, if we see here in the workspace, you will see how after 5 seconds the part is destroyed. Alright, so that will be the destroy method. Now the next method would be FindFirstAncestor. So the way you actually do this is just call here FindFirstAncestor, and you will need to pass in a string which will be the name of the instance you are looking for. So now, what is an ancestor? An ancestor is pretty much a parent of the part. So for example, there is this part, and in this case it only has one ancestor, which will be the workspace. If you, for example, added this part inside a model, and you call it, for example, object, for example, you can add this part inside the object, and now the ancestors of this part is object and the workspace. What this will do is, given a string, it will return the ancestor of that part which has as the name the string you gave it. So if you go here, for example, and type object, okay, this will actually return it, right? So we want to store whatever it returns in a variable. So here I will just type local result, for example, is going to be equal to this. Now if we print result, you will see how whenever we run this, it printed object, and this object is the instance, the model we added previously, right? Why? Because it looked for whatever ancestor, the first ancestor that showed up, called object. If we, for example, gave it something which didn't exist, for example, fourth, if we give it a string which doesn't exist, it will just return nil. So this is quite useful whenever you want to know whether a part is inside a certain folder or model. See, it returns nil. If you, for example, gave it workspace, it will return the workspace. Okay, so this would be pretty much the FindFirstAncestor method. Next up is one which is really useful, which is FindFirstChild. Now imagine you have a bunch of parts inside this part, right? So for example, I will erase the script. You have one part called first, another, for example, second, and inside this second you have one called third, for example. I will actually remove this part from this model. Right, so now we will have this part, and inside of it we have the script we are using, one part and another part with another part inside it. So now what FindFirstChild will do is pretty much look throughout all of the childs, the instance you are calling the method to, and see if there is any instance with the name you give it. So for example, I will actually call it, and this, as the previous one, has this string which you need to give it, and in this case, for example, let's just look for the FindFirstChild called second. What this will do is
the childs of this part are script, first and second, and this will just return whichever part has that name and is inside the instance we are calling it to. If we run this, you probably already know what will happen. It will print second. It will print the actual instance. See, the instance. However, now if you actually type just, for example, third, which is the name of the part we added here, it will return nil since it's non-existent. It is inside the part, but it is not a child of it. If we give it, for example, workspace, that will be an ancestor, it won't print workspace. It will just print nil. See? So that will be pretty much this FindFirstChild method. I believe it is probably the one I use the most, along with WaitForChild, which is the one which we will be covering later in this video. Alright, so the next method is FindFirstDescendant. Now this is quite of a weird one. So what this will do is just the same as FindFirstChild, but it will look through all of the descendants. So the descendants of these parts will be script, first, second, and third. Alright, so it doesn't matter how many parts you have inside of each other, it will always check them, as long as they are inside the instance you are calling the method to. So now if we actually run this, you will notice something, which will be that it will throw an error saying that FindFirstDescendant is not enabled. See? So this is because the feature is not currently working, but there is a workaround which you can use, which is using FindFirstChild. You can actually pass it the name of the string, and here next up you can actually pass a boolean, which is whether it is recursive or not. If you say it is recursive, it will act as if it was FindFirstDescendant. If you give it false, it will just not do that. So now I gave it false, and you can see how it will return nil. See? Instead, if we actually gave it a value of true, you will see how now it will actually return the third, the part called third. See? Alright, so that would be, well, it's not really FindFirstDescendant, but it is what it will do. Now, I don't really know when this feature will be out, but at least now you know how it will work. So now the next method is going to be WaitForChild. So this is also quite similar to, well, really similar to FindFirstChild. And this is pretty much just WaitForChild. You gave it a string. So for example, second, right? And what this will do is wait until it finds an instance. So now if I run this, you will see how after 5 seconds it will start waiting for the instance, and once it finds it, which is in this case instantly, it will just print it. Now imagine you didn't have, for example, this part called first. You are looking for a part called first, and it is not there. I will run this, and you will see how whenever the script sees that it has been waiting for a long time, it will print kind of a warning here, which you will see now here. See, infinite yield possible on workspace.part. So this is pretty much just in order to warn us that it is not finding anything. However, now if you actually add a part here and now you call it first, you will see how it will print the part, since now it suddenly found that the part has a child which is called first. So this is pretty much when WaitForChild, what WaitForChild does, and it is really useful, especially whenever you are working, for example, with parts on systems that are constantly adding and removing parts. You can actually use this in order to, for example, if you need to wait for the game to load, you can actually just use this to avoid any errors. Alright, so next up we have a method which is GetChildren, and this one is quite special because instead of returning an instance, it will return an array. So you do not need to pass any parameters, you just call the method and that's it, and this will return an array. If you now, for example, call this method on this part here and print the result, you will see how it will print an, well, as I said before, an array with all of the children the part has. So in this case, it will be script and second, and that's it. The third is not detected. If you click, for example, here on the second, it is returning an array of instances. So, for example, if we now added a part called first, oh my god, you added now a part called first, and you now run the script, you will see how in the array now we will have 3 elements with the one called first, the one we just added in it. Now, what is this useful for? So, for example, if you have some sort of folder or something, for example, an inventory system, if you are storing all of the player's items in a folder, you can just use this to actually delete all of the items the player has. So if you are doing something like rebirths or something like that, this can come in very useful. So how would you do this? So you will simply just do this, and now if you just did this, now what you are pretty much doing is, as I said in a previous tutorial, you can actually check it out later on. Well, you can pretty much just go through each element, which will be B, and destroy this element. So now if you run this, you will see how, if you look at the workspace, it will actually delete all of the instances that the part has. So this is pretty much GetChildren. It is very useful in the use cases I told you before. Alright, so next up we have a method called GetDescendants, which is very similar to GetChildren. You just call it like this, and now for now I will comment this code here because I won't delete it. But now for now I will just print this array and see what it returns. So now if you will look at the output, you can see how it returns an array with 4 elements. These would be the script, first, second, and third. See, script, second, third, and first. So pretty much what this thing did, it just go through all of the descendants. It doesn't matter how many. If we, for example, have here another part, it will also be detected. So as I said before, with FindFirstDescendant, this is pretty much the same thing, but it will return all of the descendants. The use cases are the same with GetChildren. They are very similar, but in some cases you might want to use this. Now this code I will actually now delete. And well, the next method is add. So now how does this work? So it will return a boolean, okay, and you need to pass it a class name as a string. So you pass it a string. So for example, you could do part. This if you can't really see autocompletion here, but it pretty much gives you a list of all the class names you can use. So what this will do is check whether this instance is the class name you give it. So in this case, if I will be checking whether this instance called part is a part. Okay, so now it's quite straightforward what will happen. Now it will just print true, right, since our part is a part. But imagine, for example, if we checked whether it was a tool, it will now print false. See? So well, this is pretty much just how is works. Now this can also come in useful, for example, whenever you have to go through all of the elements in an instance and only delete, for example, the ones which are of a certain type. Now the fun thing about object methods and such is that you can actually combine all of the things you are learning into a single code, and that is really when you start having fun and doing cool systems. Now finally, the last method we have is clone. So this is a little bit, well, this can be a little bit more confusing, but not much. So the way you call it is just type clone, and you do not need to pass any argument. Well, and you do not need to pass any parameter. So now if we just do this, let's see what happens. See, it printed part, but if we click on it, nothing shows up. Why is that? Well, it created it cloned this part here, the instance we call the method to, but it created like a new instance, but this instance has no parent. Okay, so this property called parent is pretty much non-existent, so we can't see it. So that's pretty much what's happening. So what we want to do is actually set its parent to, for example, Kindle workspace. So now if we do this, you will see how this part will actually be cloned. So in the output, you can see how now, well, it cloned the part, okay, see? And now if you actually click on it, you can actually click on both parts. And now what's happening pretty much is when cloning the part, the script ran as another time, right? So now, so like the first time we run the game, the script ran and we clone this part. On the part cloned, the script started running once again and clone the part, and this is just what's happening here. That's why there are lots of parts showing up. Now, for example, you could also just choose to actually go like set the parent to script.parent, and what this will do is clone this part here and place it inside this part. See, here it cloned it and place it here. Now another one will, well, for the same reason I told you before, it clones, and pretty much that's just what clone is used for. So most times this is, well, honestly I use this a lot when working with, for example, an inventory system. If you need to load all of the items in a menu, you will pretty much have a template which you will be cloning and modifying in order to replicate all of the items in the menu itself. So that will be pretty much the clone method. Now finally I want to tell you something, which is that in a previous video about properties and attributes, we actually used some object methods such as setAttribute, getAttribute, etc. So those are also existent. I won't be covering them in this video, but you can check it out if you want to. So anyways, all that being said, that will be everything for today's video. If you like the video, make sure you subscribe, because honestly that will help a lot to my channel, and that way also the YouTube's algorithm will help new people find the channel and learn more from me. So anyways, thanks for watching. Bye!